I'm the one that I'm going to talk about machine learning with the JavaScript. But I needed to think about this, the title of this talk. So our second speaker, Francisco Sevilla, he talked about the concept of machine learning. It was a pretty interesting talk, but now I'm going to talk more about this concept, but at the same time to land it, or how can we start, or what can be our first steps of machine learning with JavaScript. And with this, I will start and avoid confusions. So that's why I'm going to start with deep learning versus machine learning, and this different concept, because we listen this concept, but we confuse e-learning or deep learning or machine learning, and we think it's the same. But with this slide, we have this very clear example of how the relation of this concept. So the biggest concept is in artificial intelligence. So this is a very huge area, and of course in this area of the computer science, there is a lot of implication, not only machine learning as a concept, but cognitive methods and many others scientific areas that can be outside of the computer part. And also in artificial intelligence, we have machine learning. And maybe you are developers in this area, and maybe you've been hearing this word for many, many years. And I think it's a trending, well, not trending, but I will tell you later my ideas about it. So machine learning, you can see a lot of methodologies that are used to make automatization. And machine learning as a science is how you train your machine to learn something. We can define it like that. I know that the definition is longer, there's more technicalities, but I also need to mention you that I'm not an expert in machine learning or deep learning, but I love to explore these two concepts and understand it. Then we have another concept which is neural networks, which are tools that are introduced, and you will see that this concept is very important inside the machine learning area. So a neural network is like a structure where we have an input, can be data, information, and then there is a middle layer. It can be simple or complex, where the magic occurs. All this part of the algorithms take place. So we change for a central information to output information. And with this, we arrive to deep learning. And basically it's not as deep learning because you are in a deep way learning, or the machine is in a deep way learning. No, it's more like, or I read somewhere, it's more like this data that are like input can be more and more bigger, and that's why it's deep. So we can have a better output. It's more or less like that. Hopefully I will not confuse you. So very fast, I'm showing this slide, and we have this information. And what is important here is a difference of a classical programming versus machine learning. In the first one, classical programming, we have rules and data. The rules, just imagine a program with conditionals or other things, and that's the program. And the information is parameters of the information. And with this, we can trigger something, answers, as you can see in this layout. And then we have machine learning, where we add the data, the input data, and then output or answers. And with these programs, we arrive to rules. And this is important. Rules are inside machine learning. And these rules define how the algorithm learns. And the classical example is images classification. Just imagine this type of algorithm, and with one image, it's transformed to a micro units, smaller micro units, and they are like a matrix. And a matrix, you can see it with the lens of the mathematics, or a set of data that will define the structure of the image. So with all this matrix, we can identify the colors in each region, and this algorithm detect colors, interpret them, and with that, the understanding of the patterns of colors. Those patterns can have like a shape of a cat, and if you show a lot of images of cats, this algorithm will find a common pattern with these characteristics, maybe shapes or colors, and inside of the image. And with this, you are training your machine. And about the theory, the question is, why deep learning? Why right now? So this area, well, it's been for a lot of years. There's several models that are currently used that have this origin in the 80s. So why now? Or in the recent years, we've been hearing a lot of this topic, and it's because of three things. The first one is hardware. And for example, nowadays in cloud computing, we have these computers with more power. And so something that is important when you train is that you need a lot of power of computing. So the normal CPU is not something that will give us the best performance or to run big data sets. You need smaller servers, but in parallel one to the other. And this is GPUs and these video cards. So with this, we can see nowadays that we can have a cloud service or a cloud computer with a lot of GPUs that work in a parallel way. You rent it for hours and that's it. So some years ago, it was very expensive or impossible. So this was the first step. And so the machine learning can be more like there. Then we have the data set and benchmark. That is all the information that is in the last years. We're talking about that in the last 15 or 20 years with the boost of internet, social media apps that are recovering data of ourselves, of our families or friends. All that information is very useful, not only in a corporate level, but it's important how people, developer companies, or ONGs manipulate the information to interpret those patterns. For example, the favorite food of a region of the population, and the advances in algorithm. not only the ones that we already have, but a lot of these advances in a research level have been in the last 20 years. So they are not private algorithm, but public, and are part of the models in libraries or in the community. And in general, or another thing that I want to mention is the importance of deep learning in the browser. So one can think that with JavaScript is not possible due to the language performance, or there are not enough tools or ecosystems such as Python, but precisely an advantage or several advantages of deep learning based in the browser are this cost, reduced cost in the server. So you don't have to process all your algorithm in a server. You can do it in the user or in the client or customer part. So Tensorflow.js library allowed us to train this in the browser. Your algorithm is running in Google Chrome. So we have that accessibility. So you can run this algorithm inside mobile. And with that, we have a lot of versatility. And then we have, for example, the privacy of the data, and also we have the GPU, instantaneous acceleration. And with this, we do not need GPU in a cloud service, but in the same browser. Of course, the data privacy is that we are in the browser and we can do face recognition and identify, I don't know, a feeling, a emotion. This imaging classification is through the client. So with this, we have the privacy of the data. And also, or last, we have this instant access through a URL. And with an internet connection, you can have it. So let's start with this. I want to talk about Tensorflow.js, this Google library based in Tensorflow. You need to remember that TensorFlow is built for Python, mainly for Python. It's like a gateway that are trained in TensorFlow, and they are ready in this port, and we can run it with JavaScript, with the language in the customer, and is in GS, so we can train those Node.js and offers CDN with pre-trained models. And you can ask, why is this operation in GPU is using WebGL? It's a technology in this browser. And what is important is WebGL. It was not the best idea. It was not so good. And with this, the apps will need more memory, will be heavy apps. And they are using, looking for alternatives. And to change WebGL, we can think, I don't remember, with other future alternatives better than WebGL, but right now is with this library. And before we start with the code, I just want to mention three concepts. Tensor is the first one. It's just a computing concept with a lot of net, or an array with a lot of input. And this is a statistical term where we have rules with data, rules given to data. And then this neuronal network that we can have this logic of the algorithm, so we can interpret this data, and with this we can define the rules. Now let's see the code. Just to start, very quickly, you can see how easy is starting with this language. So this is the first model base. So the name is MobileNet. It's very popular in Tensorflow.js, and this is to classify images. So the first step, and this comes from Tensorflow.js, is we can use all these models from a CDN. We have these 3 imported models, GS, and then we have MobileNet and a classifier, KNN. And I will not go deeper in this, but this is a classifier model based on data. And Francisco, in his talk, he explained about what was KNN and a classifier, and it's the same concept. So here we have defined these tags for buttons with these IDs and a video that will allow us to the webcam. Here we connect MobileNet, and this is where it's interesting. MobileNet has inside this code that I will give it to you. So if you want to look it further, and then you will see how this behaves. What happens here is we started with this function, which is act as asynchronous. And what happened here is you change the model through MobileNet. We are having this information from the server, and then the webcam. This is the tensor that will take the data from the images. This is an API that is inside Tensorflow.js and allowed us what is in the video. Then we have in this example another function which is async, and is at example and capture the image is a Python frame by frame in the webcam. And here, this is a activation variable, and this allowed us use the KAN classifier. In this case, it's an image, and each captured image is with this variable through the webcam and the true parameter with this condition. This classifier, which is an outside variable already defined, through this method, receive this parameter, which is classified, and then activation. And class ID, we will see it later, is the button that we have here, 4 different ones. But let's continue with the code. This method is very important. This release memory with these methods is that when it's running with the client, remember, this is client, not server. They use a lot of GPU, and they need this. So that's why they need a lot of resources. So with this, we free memory or release memory. So there will be not a memory link. And here we have more. We select the 4 tags and we add with a click, and we called an event add example. And as I mentioned, with add example is already here, receive the class ID, and how the bottom is a tag 1, 0, 1, and 2. And then we have this other loop, infinity loop, is the image classifier. So frame by frame, each image of the video is captured while the video is running. So with this classifier, if the classes is higher than 0, we take this image with the webcam. It's a webcam capture. So several images that are running like in a real time. And later, again, we have this variable activation. Is very similar of what is running here. That is uploading one of the models, EONet, with these parameters and image. And last, what we do is we have the result from the prediction that that makes the classifier. So in this example is this preload model, and then give it with this result. And we have an array of classes from A to D, and we return through console tag with these upper results and with this string, prediction and probability. And the values are here in the DOM, each tag that exists in the class, and the probability that in this example is the result value of the of this model. So each time we load the model and we activate the model, we need to have this dispose, because with this we will have a release of memory. And then this mention to TensorFlow to take one of the frames of the video, and then we execute this app function. So with these small files, well, this is not so small, we have this model and client model, and let's see the result. So let's enter here. This is the name of our file index. We open it. And here, let's wait a little bit. Okay. As you can see, this we can access to the camera, and hopefully this will not slow down because my camera needs a lot of resources, but let's inspect what is happening right now. Yes, the model is right there, and now it's waiting to create the frame for the camera. Well, normally it's not this slow. I don't know if it's my internet connection. I don't think. Maybe it's the RAM consumption. Now I have access to the camera and the model. So I have here the 4 buttons that I already mentioned, and each and every one of them can read one image. In the A, I will say, for example, my face. This is model A, and I can have multiple frames. The idea is just to have a lot of frames of any object, and then I can move from the image and put my phone here and save it. In B, or in the model that is B, then I can have another object like this, booklet. This will be in model C, and wait to react. And in model D, anything else, I don't know. I don't know. I don't think my mouse. And save it. So with this model has 4 type of inputs, and as you can see, the prediction is here is A with all the photos or pictures. I'm in A group, then B group is phone. And if I move and I put this object will be B, as you can see in the slide. And then notepad C. But what happens if, for example, I have a book? The prediction is C, so it's okay. It's working. And I don't know with D and the mouse. It's a little bit confused if it's a mobile or a mouse. So this is one of the one of the application that MobileNet has. You don't have to worry to pre-train in the server. It's directly in the browser. And now I will go back to the slide. Well, here is MobileNet. This is the first algorithm. And the second one is Coco SSD. This is another example. It's an image classification algorithm, but the difference is it does not classify through the frame, but with objects. In other words, this is an image classification, and this is an object classification. And OSD is preloaded in several models, like this, for example. There are different objects in just one image, and with a lot of confidence, it can be detected, and how proximate is one to the other. And I will show you another example. And remember that all these examples will be in eHub. And let's go to HTML in objects. And we can omit this very fast. It's just an HTML with a presentation text for you. But what is important is this section where I have this button for webcam and the video. Remember, as the other example is to preload the webcam. And this is very simple. And how to connect it from the CNN or Yarn, a package manager. And here is for you to know the path. And we have the Tensorflow.js, which is the general library, and each model load separately. This, in this case, is Coco SSD. And here is where the script is connected for the object detector. There's not much time to explain all this code, but let's go only to the important areas. This upper part is a general part, so we can read the content. For example, this allowed us to access, for example, demos and webcam. In this case, is the video. And this small function is just to verify if we have access to the webcam, and if we have the permissions. If we have the permission, we enable the access to webcam. This is not Tensor.js, but it's something that is internal, so we can access to the permission of the browser. And here is an important thing. Here is where you enable the webcam, and what you do is to receive this event, this function that is enable cam, that is connected with this button, and then through target, what is in this button, there is a remove. Once we made a click, the button will disappear. And right here, there are parameters for the user media and to activate again the stream to the webcam. This is very important to do it before capturing the model, so we can read what is happening through this video, so we can have all this frame. Then we have another function, predict webcam, and starts classifying each frame of the stream. Maybe, well, the code is not so beautiful right here. I didn't have the time to clean it up a little bit, but you can see, or what does is to take this model. So the fact, well, I have very little time, but what is important is to take each prediction and the percentage of each frame, and if it happens, it's there. So the last area is to where we charge this model, and through these parameters, this is the core of this model. And let's run this function, or sorry, this program in HTML. And you will find this detection of some objects with TensorFlow, and I say some of them. So we enable the webcam. Let me show you finally how this. Once you run, once the client have this active, you will have something very similar to this, the percentage of everything, and that's it.